This video is on the factors that affect climate, in particular wind. So let's get started. The first two questions we need to ask is what is a wind and how is it created? Imagine that this square is an air mass. This is a very dense air mass. The molecules, represented by dots within the air mass, are very close together, making it dense. Because the air is dense, we say that the air mass has a high gravitational pull. Thus we call it a high. Now let's look at another air mass. Again, this square will represent it. This time, let's make the air mass less dense. The molecules within this air mass are not as close together as represented by the dots. Because the air mass is less dense, we say that this air mass has a low gravitational pull. Thus, we call it a low. Now, let's get back to the very dense air mass. Because we said it had a high gravitational pull, meteorologists put an H in it to designate as a high. Highs are often associated with cooler air than the other air masses surrounding it. The less dense air mass, the meteorologists put an L in it to designate it as a low. Lows are often associated with warmer air than the other air masses surrounding it. Very dense air pushes less dense air out of the way all of the time. The result is that dense air moves in to replace less dense air. This movement of air from a high to a low is known as a wind. Thus, a high always blows to a low, never the other way around. So, now that we understand that the differences in air pressure produce wind, let's look at this diagram so you can see the movement of air. Point 1 shows the heating of the ground by the sun warms the air above it and causes the air to rise. The ground area is a low pressure system. Over at point 2, the air is cooled down enough and starts to sink. This produces a high pressure area. Number 3, air at the ground moves from the high pressure area to the low pressure, creating winds. So you can see that winds do not just move horizontally, they move vertically in all directions, all depending on the pressures of the system. Okay, so now let's look at the global pattern of wind. Ask yourself this question: where is the hottest place on the planet? The answer is the equator. Since lows are associated with warm weather, let's put an L on the equator. Next question: where is the coldest place on the planet? If you said the North and South Poles, you would have been correct. Since cooler temperatures are associated with highs, let's put an H on the North and South Poles. Okay, now at 60 degrees north, we know that there is a global low. As a result, we shall put an L, and at 30 degrees north, there is a global high, so we shall put an H. The southern hemisphere mirrors the northern hemisphere, so we will put an H to represent a high at 30 degrees south, and at 60 degrees south, an L to represent a low pressure. Okay, so if we follow our theory on the directions that all winds must travel from a high to a low, then it is very easy to see the general patterns of winds. Let's start at the North Pole. The wind should blow from the Arctic high to the low, and the high at 30 degrees north should blow in two directions. That is 60 degrees north and down to the equator. In the southern hemisphere, the wind at 30 degrees south must blow towards the equator and 60 degrees south. Finally, the wind in Antarctica must blow towards 60 degrees south. That is good in theory, but sorry folks, this is wrong. Why is this wrong? Well, because we've not taken into account the Coriolis effect. What is the Coriolis effect? It has to deal with the rotation of the Earth. In the northern hemisphere, objects tend to spin to the right of the direction they are heading, and in the southern hemisphere, objects tend to spin to the left of the direction they are heading. So what is the Coriolis effect on winds? Let's go back to the diagram we had on Earth and the directions that we indicated the wind should travel. In the Arctic at 90 degrees north, if we take the Coriolis effect into account, then the wind moves towards the right as indicated. Watching this video, you may say, wait a minute, you're showing the wind blowing to the left. From your point of view, that's correct. But remember, the Coriolis effect works on the direction that an object is traveling from. In this case, the wind is moving from the North Pole towards the south. Thus, the wind is blowing to its right. Now let's do the same for the wind at 30 degrees north. It blows to the right as it heads towards 60 degrees north, and again to the right as it heads towards the equator. At 30 degrees south, it blows to the left as it heads to the equator, and again it blows to the left as it blows towards 60 degrees south. Remember, everything south of the equator blows left. Finally, the South Pole blows left as it heads towards 60 degrees south. So what does wind have to do with all factors that affect climate? We know that the characteristics of an air mass is made up mainly of its moisture and temperature content. We know that air masses travel with these characteristics. It is wind that make the air masses travel possible. Well, that's it for this video. Don't forget to check out other factors that affect climate in this series. They are latitude, ocean currents, elevation, relief, and near water. Hope you're having a great day. Bye for now.